All right, friends. We're going to practice with the ratio test. That's the plan. We're going to practice the ratio test. That song that we sang yesterday, that's lesson 10. We're going to make it. It's going to be good. I'm going to show a couple of those. I'm going to give you a couple of do on your own in the privacy of your own home. And then I'm going to do a quick side note. We're going to be done. This is a short one. So, consider the summation, n runs from 0 to infinity, of n factorial times x minus 2 to the nth power. What is its interval of convergence? Whenever you're asked for an interval of convergence and you don't recognize the series as geometric, you want to recognize it as something that is as close to geometric as possible, and the way to do that is through the ratio test. So we are going to use the ratio test. And the ratio test says, row, row, row your boat gently down the stream. Its the limit as n approaches infinity of the absolute value of the n plus 1th term over the nth term. The n plus 1th term looks like this. The nth term looks like this. So a little bit of algebra before our calculus here. N factorial, n plus 1 factorial leaves you with just n plus 1. Nth power, n plus 1th power just leaves you with that. And so we're going to take a limit as n approaches infinity of that. Oh, let's not do it that way. I'm going to take a limit as n approaches infinity of n plus 1 times x minus 2. Wait a second. That blows up. So here's the question. If the limit is infinity, for what value or values of x will that thing inside the bars be less than 1? And there is only one answer. There is only one answer. And that's the center of the series. When you get a limit that cannot possibly be less than 1, the only value for which the series will converge is the center of the series. It diverges everywhere else. That's the name of the game. So whenever you see interval of convergence, you are saying ratio test, find rho, see what will allow rho to be less than 1, go. One more. Question. This won't be an interval of convergence question. This will be a does it converge question. Does it converge? Everybody's favorite game. Does it converge? If you want to know, does a series converge, and the series is not geometric, this is clearly not geometric, you can apply the ratio test. Because the ratio test takes series that are not geometric and turns them into series that are geometric. So, row, row, row your boat gently down the stream. Its limit as n approaches infinity of the absolute value of the n plus 1th term over the nth term. A little bit of algebra will help us out here. 3 to the n plus 1 leaves you with just a 3. There is no significant difference between n cubed plus blah, blah, blah and n cubed plus blah, blah, blah. And so that leaves us with 1/3. The ratio test says if rho is less than 1, the answer to our question is yes, the series converges. Yes, the series converges. I'm going to leave you with a couple of things to think about. First thing to think about. Does the series, n goes from 0 to infinity, 2 to the n times 3 to the n over n to the n, converge? That's something to think about. The other is to find the interval of convergence for sum n goes from 0 to infinity, x minus 1 to the n over n factorial. It's a nice thing to think about. Those are things to think about after you hit the pause button. Close out this video with a side note. I'm just kidding, it's not really a side note. It's not really, well, whatever. I want to find the sum as n goes from 1 to infinity of 1 over n times n plus 1. I want to find the sum of that series. And that's more difficult than you might imagine. That is not the easiest thing in the world. Because you start substituting values, and all of a sudden, nothing is helpful to you. Nothing is helpful to you. I mean, you can sub in 1, and you get 1/2, and then you sub in 2, and you get 1/6, and you sub in 3, and you get 1/12, and you sub in 4, and you're going, I don't know. I don't know. I have no idea. I have no idea. But I start thinking like a calculus student, and I say, wait a second. Teacher gave me this fraction. It's a proper fraction with a factorable denominator. And since it's a proper fraction with a factorable denominator, then it can be expressed thusly. And a and b can be found, because a times the other denominator plus b times the one denominator has to equal the numerator on the fraction on the right side. This sounds vaguely familiar to me. And so we make a couple of strategic substitutions, just like we did during partial fraction decomposition. We get negative b equals 1. And then we let n equals 0, and we get that a equals 1. And so what do we really have? We really have a sum, 1 to infinity, of 1 over n minus 1 over n plus 1. Well, now we can start subbing in some terms. If n is 1, we get that. If n is 2, we get that. If n is 3, oh. So everybody drops out through here. This guy sticks around, and these get small. And so our sum turns out to be exactly 1. Moral of the story, if I ask you to find a sum, and that sum is not a sum of a geometric series, and that sum is not one of the series that you had to memorize, and that fraction has a factorable denominator, chances are it decomposes just like you learned how to decompose. By the way, series like these have a special name. This series is called a telescoping series because years ago, people used to be able to fit telescopes in their pocket because they collapsed. I'll give you a moment to figure out why a collapsing telescope is a good way to think about this infinite series. Well, that's probably enough time. Okay, so there you go. That's lesson 10. Hope you enjoyed. See you soon.